Iron is an essential trace element necessary for numerous biochemical and cellular physiological processes. Meat, seafood, and poultry contain both heme and non-heme iron. Iron in plants, iron-fortified foods, and iron supplements contain non-heme iron. Both forms of iron are released from their food matrices by proteases in the stomach and small intestine. The bulk of iron absorption occurs in the proximal small intestine. Iron absorption starts at the apical brush border membrane of the epithelial cells of the intestinal villi. Here, there are two separate processes for the intestinal absorption of heme and non-heme iron. Heme iron transport begins with heme binding to a heme receptor located in the brush border membrane. Receptor-mediated endocytosis results in the internalization of the heme receptor complex. An endosome fuses with the vesicle, protons are pumped into the fused endosomal vesicle, and the heme is released from its receptor as the vesicle becomes acidic. Heme oxygenase within the endosome catalyzes the removal of iron from heme. The iron remains in its reduced ferrous state as it is transported out of the endosome by the DMT1 duodenal metal transporter 1 iron transporter. The reduced ferrous iron in the cytosol becomes part of the labile iron pool, which contains iron-dependent enzymes and iron-binding proteins. Non-heme iron is in its oxidized ferric state and must be reduced prior to its transport. D-Cyte B, duodenal cytochrome B, has ferric reductase activity and reduces the ferric iron to ferrous iron. The DMT1 transporter then transports the reduced iron across the brush border membrane. The reduced iron is then added to the labile iron pool. If the person's iron status is elevated, then the iron can be stored in ferritin where it becomes oxidized as part of a ferric hydroxide phosphate crystal. Iron not bound within the labile iron pool, or ferritin, will be transported across the basolateral membrane. Ferroportin 1 transports ferrous iron out of the cell. Iron is oxidized by hephaestin and binds to apotransferrin for transport in the portal circulation. Iron bound to transferrin is also transported into the intestinal cell at the basolateral membrane. The holotransferrin binds to the transferrin receptor and is taken into the cell via receptor-mediated endocytosis. The vesicle fuses with an endosome. The vesicle becomes acidic and the transferrin releases its ferric iron. The released iron is reduced by STIAP, 6-transmembrane epithelial antigen of prostate, and transported across the endosomal membrane by DMT1. It then enters the intracellular labile iron pool.